Okay, we're going to go over dimensional analysis examples today. Yesterday we went over the procedure. The question on the board, what is the density of a 22 kilogram object in a 11 milliliter solution? So that's a review. What did you get for number 1 on the density problem, Jeremy? 2 kilograms per milliliter. So this is review activity number 1. We have to find the density, mass, volume. What's the density in number 1, Daisy? (22). Why is 22 the density? Number 1, read it. Tell me again. So what is the density in number? Is the density given in number 1? What is the mass, Clayton?
The mass is 22 kilograms.
And then the volume is what? Caitlin, what was the volume in number 1? 1 million. Okay, so the formula is on the board. What is the formula for density, Robert? M over V, good. M over V. Mass is 22, volume's 11. Where does the 22 go? Top or bottom? Top. Where does 11 go? So all I have to do is divide 11 milliliters. So all I have to do is divide, and the answer is 2 what? Kilograms per milliliter. Very good. Number 2. What are we trying to find in number 2, Kelly? Weaver. Good job, mass. Trying to find the mass. So we've got to be given the density and the volume. Jeremiah, what's the density in number 2? Okay, 12 kilograms per milliliter. What's the volume, Megan? What? 12 milliliters. Very good. So I have to use the formula. Robert, what's the formula? Okay, what number did I put in for D? 12. What number did I put in for M? Nothing. What number did I put in for volume? And that's 12 milliliters, kilogram per milliliter. Remember what we did yesterday? What did we do? Simplify. Cross multiply. So 12 times 12 is? And then number 30. What are we looking for, number 3? The volume. What is the density? Kelly Rodriguez, what's the density in number 3? Very good. 5 kilograms per milliliter. What's the mass in number 3, Harley? So you're looking for volume. What's the formula, Robert? What number did I put for D? Somebody? 5 kilograms per milliliter equals, what number did I put for M? 10. And then V. Put that over 1, cross multiply, or whichever way you do it. 5 times V, just write them together. 10 times 1 is 10. Divide both sides by 5. The number. So 5's cancel out. V equals 2. question on the physical property of density. Real quick, Lachey, physical properties. Tell me something about physical properties. Do they change the state of matter or do they not? Huh? They do. Very good, they do. Physical properties change the state of matter. Now we're going to shift gears into dimensional analysis. Somebody tell me from your quiz. 1,000 kilograms equals how many? 1,000 grams equals how many kilograms? 1,000. What did I say? 1,000 grams equals how many kilograms? Remember, we'll go back. I gave it to you yesterday. 1,000 grams equals, I'm going to rewrite them, 1 kilogram. Remember that. Write it down again. 100 grams equals 1. What did kangaroos do? What comes next? What's the H stand for? Hectogram. Opt, which is hecto. Good job. 10 grams. 0.10 grams. This gram. 0.100 grams. 0.01. 0.0001 grams, 1 milligram. So we're going to use these as air dominoes. Or use them as our ratios. These are called conversion factors. Remember the dominoes from yesterday. Okay, so what I mean by that, I'm going to redraw these as a domino. One side I'll put 1,000 grams. This side I'll put 1 kilogram, which would be, could be 1,000 grams to 1 kilogram, or I could say 1 kilogram to 1,000 grams. Anybody lost? Everybody with me somewhere? Anybody lost? Okay. All I've done is write this as a domino. 1,000 dots for 1. And then remember yesterday with the dots, one of them goes over the other. It can be either one. The next domino was 100 grams to 1 hectogram. That could be written as 100 grams over 1 hectogram, or 1 hectogram over 100 grams. What's the next domino? We're going to do the 10. So 10 grams equals how many decigrams? 10 grams equals how many decigrams? 1. So that could be written as 10 grams over 1 decigram, or 1 decigram over 10 grams. Anybody lost? Okay, so we're doing what we did yesterday. These are our dominoes. I'm just referring to them as that so that you can remember yesterday. After 10 go, we'll start on this side. 0.10 grams to 1 decigram. That was decagram. So that can be written as 0.0 grams over 1 decigram, or 1 decigram to 0.0 grams. It just depends on your problem. Anybody got these three? Anybody got the three black dominoes? Anybody don't have them? Come on. Move up that one. So our next domino was 0.01 grams is 1 centigram. So that can be written as 0.1 grams over 1 centigram, or 1 centigram over 0.1 grams. Try the next domino on your own. Try this, the last conversion factor. This one, the last one. On your notes, it's this one right here. Put that, see if you can write that as a ratio. Okay, what goes in the first block? 0.001. Got too many zeros. Grams. And then in the second block? 1 milligram. Okay, Michelle, what's one of the fractions? 0.001 grams over 1 milligram. Very good. Or it could be written as what, Jeremiah? So those are dominoes. We're going to use the ratios. That's just how we have come up with the ratios. So we're going to use one of these in each of our problems. So let's get started with problems. Anybody got this? Anybody still need it? Okay, I'll give you about 10 seconds. First problem. We're going to start off easy. What's the answer to this one? 1. But so that way we can check ourselves. We're going to set it up mathematically. Remember yesterday? What were we doing yesterday mathematically? Who remembers? What? Say louder. What? We were dividing some. What else were we doing? Cross multiplying, cross canceling, multiplying. We had fractions, right? So this is our problem. The first thing you do to see how many kilograms there are in grams. We know there's one, but we're going to do it mathematically. Well, this is called the given amount. That's the given. So if I were to say what you're given, I'm talking about this amount. I put the given over 1. I have to make it a fraction. So if I put that over 1, I don't change anything. Now for my second fraction, I want something to cancel out. Now remember yesterday we did the dominoes, we had 5, we put 5 down there. We're not looking at the numbers. We don't want the numbers to cancel out. You want the units to cancel out. So what unit is up here in top? Grams. Go ahead and mark those out. Whatever unit is in this numerator, the same unit, not the number, goes in the denominator. Then the unit you're going to goes in the numerator. Raise your hand if you got lost. Anybody? Good. Remember, this was yesterday. And we had the dominoes and we put them underneath. Okay, go back to what we just wrote. I'm going to take this one off. We're in grams and kilograms, right? Okay, I want kilograms on top. So which one of these two fractions would I use? A or B? Anybody not see that? Why would I use B? This is B. So what number is next to kg? 1. So that's I put the 1 up there. What number is next to 1,000 here? I put it below. Now in this problem, from here you just simplify. You can cross cancel 1,000, 1,000. They'll go into each other how many times? So what's the answer? And is that not a true statement? That's a true statement. Let's stick with this same thing. Let's do 5,000 grams equals how many kilograms? Is that hard? That's not too hard, is it? Can you kind of see what we did yesterday with the dominoes, where we canceled the numbers out? Now we're just canceling the units out. So let's put our 2 fraction bars up. Bam. Bam. What is the given in this problem? The given is, so it goes in the numerator of the first fraction over 1. Okay, now think, that's what we just said in this one. What unit is here, everybody? Okay, it needs to be cross-canceled. There's only one place I can put it, the top or the bottom. You got that, Robert? Now what unit are we going to? Okay, so I'll go back over here to our formulas. Which one of these has kg on top? A or B? A or B? How many says I use A? Raise your hand. Who says I use B? Good job. So I'll put B. What number is next to kilogram? 1. What number is next to grams? 1,000. Okay, so I can cross cancel this. 1,000 will go into 1,000 one time. 1,000 will go into 5,000 how many times? So now you just multiply. 5 times 1 is 5 kilograms. On bottom I have 1 times 1, which can be simplified as 5 kilograms. Now let's flip it around. Can we flip it around? Will that confuse you? Let's try not to. What if I have 4 kilograms is equal to blank grams? As Scooby would say, whoa. But is it a problem for you? No, you can do it. Harley can do it. Becca can do it. Mark can even do it. Why don't you stop him down? Let's see if Dylan. Okay, Dylan, for your fraction bar, what's the given in this problem? What did I do to it? That's the very first thing I did. No, before I cross multiply. Before I do all that, I put the given over 1. Do that. That's the first thing. First thing, put the given over 1. What unit, Daisy, am I going to cancel out? Good, kilograms. So that means I put it up here, right? Lachey, did I put it up here? Did I put it on top? Did I put it on top back there, Kelly's, Jennifer's, Joe's, Jesus. Jesus, did I put it back there? Did I put kg on top?
No.
Which one? How many says I put kg on top? Raise your hand. How many says I put it on bottom? All right, y'all smart. Kilograms on bottom. And I'm going to what unit? Grams. Now I go back over here. I'm looking for grams on top, kilograms on bottom. Grams on top, kilograms on bottom. Grams on top, kilograms on bottom. Which one do I use? A. What number is next to grams?
1,000.
What number is next to grams here? Still 1,000, it's the same. Okay, so here I'm going to put 1,000 in the top. Put 1 below it. No cross cancel, I'll just multiply. What's 4 times 1,000? Grams over 1, which is 4,000 grams.